with that, I'm going to introduce Dr. Kenton McHenry. He is the Senior Research Scientist at the National Center for Supercomputing Applications at the University of Illinois at Urbana-Champaign. He's the Deputy Director of NCSA Scientific Software and Applications Division, the Principal Investigator of DIBS Brown Dog, and co-lead of NCSA's Innovative Software and Data Analysis Group, which works with researchers to build novel tools, services in support of scientific data needs. And is there a story behind that Brown Dog title? I'm not familiar with it.
Yeah, I touched on it last time. It has to do with basically there's a lot of different ways to manipulate data, and it tries to wrangle those. And so it's basically a mutt of different kinds of software. So that's where the name Brown Dog comes from.
All right, great. Well, with that, I think we're ready to hand it over to Kenton. Thank you.
Okay, thanks. So today I'm going to talk a little bit about the National Data Service Consortium and kind of the activities we're doing there, and show you what we've been developing as part of that. So the NDS activity is largely towards supporting the publication of data, scientific data specifically, and linking it to the papers that talk about it, that have produced that data, and overall leading to its reuse so that other scientists, potentially even within different domains, can discover that data and do stuff with it pretty more easily. And overall, the goal is towards advancing discovery within science, towards making new discoveries that are currently difficult much more doable in the future. The kind of story that I lead off with, I've been using these days is from the Washington Post from a year ago, that kind of highlights what we want to see more of. It basically discusses an effort out of NIH to basically bring together a bunch of different data sources that actually cross different countries. And was brought together over a number of years to basically make this discovery in the brain that led to some insights into how schizophrenia is triggered. And so this article actually touches on how difficult it was to do this even now, and how pretty much impossible it would have been done just to even do a few years back. The program officer from NIH basically talks about how many scientists don't want to give out their data, they want to be buried with their data, and how it was a major accomplishment to even do this. And so I would say in terms of what we're doing with the NDS, it's towards enabling these kinds of things so that they're much more frequent, less worthy of a story kind of scenarios. You know, this is kind of the way things will be, where pulling together different data sources is just the way things are done. And so with regards to publishing scientific data, there's a couple of aspects to it. The most common one being, you know, you got to have somewhere to put the data, where to store the bytes. And I think a lot of people tend to focus on that, but that's only really half of the story. Everything else that comes after that is crucial. And in these presentations, I just throw up, you know, a couple of ASCII bytes and ask people, what is that right there? If anybody out there can answer me, well, what does that mean? Anybody? Mike? It's basically, if you watch Hitchhiker's Guide to the Galaxy, it's the number 42. You know, the answer to everything. And what I've tried to highlight here is basically it's difficult to say what, you know, those bytes, those bits mean without, you know, information around it, without the knowledge that it was ASCII. In more complex scenarios, you know, the format of the file, indices over collections of files so you can find what's where, metadata around the data so that you know what's in what, and all kinds of other things around access control, data transfer, data transformation, analysis, and so forth. All these are services that are above and beyond just the storage of those bytes, and are crucial for data publication and data reuse eventually. So we focus on that. And so once you get down that world of data services, there's a huge landscape of things that are currently being researched and developed to kind of deal with these things. For a scientist getting into the world of putting together a data management plan, there's a lot of different tools out there. A lot of them are redundant. A lot of them are contained within specific domains and not really known about beyond that. And it makes it difficult in terms of using these things, and also connecting them together in the case where something more could be done by taking one aspect of one and combining with another aspect of another, and to do something even bigger. So the National Data Service Consortium is really engaged with regards to publishing data in the sense of kind of navigating that landscape of services and tools that are out there, and really addressing interoperability of those tools and services. And so we try to work closely with the Research Data Alliance on that aspect of that in terms of kind of defining what those standards are for interfaces and interoperability, and on our end trying to implement those in some of these components that we work closely with. And so in that, we have engaged with a number of universities that attend our consortium meetings, the supercomputing centers, national labs, cyber infrastructure efforts in the data nets and the data infrastructure building blocks out of NSF. As we are doing here, engaging with the big data hubs, EarthCube and the RDA and so forth, basically trying to map the landscape of what's out there and trying to pull together pieces and address, interfaces and protocols that we could potentially implement, or at least motivate the implementation towards, foster the implementation towards making it easier to connect these components together. And the last aspect I would mention too is we also engage with publishers themselves. Since we are talking about publishing data, we engage with like Nature, Science, Elsevier, and so forth, and representatives from them typically attend our meetings. In terms of the cyber infrastructure components that we engage with, participants of our activities, we try to highlight certain aspects. One is basically they're each trying to engage some big data challenge that's out there in terms of meeting some need in terms of access control, data movement, and so forth, something that's needed by the scientific community to use data, making science more effective, and at some level, figuring out how to, within their current funding sources or by going after other funding sources, specifically addressing interoperability. And not just one-off kind of scenarios, but specifically some way of doing it in a way that basically can be done, meet more than one need through some sort of interface that many people could potentially use. So we've been basically, some of our work with regards to the community activities have centered around mapping the landscape, as I mentioned, the components, kind of breaking things down into individual pieces of a data infrastructure from, as I mentioned before, authentication, transfer, storage, curation, analysis, exploration, and so forth, and kind of mapping these into some of the components that are out there and what does what, where are there missing gaps, where are there 10 different things doing the same thing, and those kind of indicate where maybe an interface really could be used so that one could pick one and swap it out over time if they need to, and so forth. Try different things out and we'll see what meets their needs best. And overall, really work towards, this is a concept I think that first came out of the RDA, is kind of doing for this data world what happened for the internet long ago, where basically there were lots of components vying for each piece of the internet back then, and it wasn't only until there was the NSF that we should use TCP/IP, that the HTTP and HTML and all these other protocols came to be, that things kind of for the user at least became kind of cohesive, where to the sense that they could pick any browser that they wanted, it would still work with any other technology in the background. A web administrator could pick any web server they wanted, they felt was best, that they knew best. It would still work with everything else in this picture as well. And so kind of doing that and kind of taking the name from the original data net solicitations out of NSF, moving towards a data net, where basically the same kind of thing, where web servers are replaced by archive technologies, and other services like DNSs are replaced by transfer services and transformation services and so forth, specifically towards addressing the needs of the scientific community, but perhaps at some point addressing the needs of the general public at large as things evolve. And so this kind of leads into where we have been moving development-wise. So through some seed funding from NCSA and some efforts out of SDSC and Argonne National Labs, we've been working towards developing some tools to kind of foster this movement towards interoperability. And so the first one is we call NDS Labs, and this basically has three components. The NDS Labs Workbench is the main software component of this. And what it largely is sort of an app store for these data management tools and services. A catalog of these things that are being researched and developed and are under active development, perhaps not finalized at the moment. And so a user or a new project that's looking for data management tools could potentially go here, find tools that meet that they need for curation or sharing data and so forth, and actually deploy them. So the tools are basically contained within this app store for these data management tools as Docker containers and managed through Kubernetes. And so from here, a person could basically find the tools they want and run them, run 10 of them, and try them out. And so what that kind of looks like is that you add them to your workspace and you select launch. It pulls the dependencies of those tools with them. So in this example here, Cloud out of DataNet Seed, it pulls MongoDB, RabbitMQ, and so forth. For Dataverse, it pulls Postgres and Solr and so forth. And these are all Dockerized components as well. And so you can launch them and try them out for yourself. So if you go to this YouTube video down here, I won't do it now for lack of time, you can see a demonstration of this actually being run for a couple of use case scenarios that we showed at one of our previous workshops. So that's one of the tools we've been developing. NDS Labs also provides resource allocations to cloud resources scattered across SDSC, NCSA, and others. to kind of help more advanced users try out new technologies and work towards interoperability. I'll just mention that the NDS Labs Workbench also is meant for that interoperability development aspect. It supports various web-based IDEs, methods of accessing data on these tools, accessing terminals, and so forth, so you can actually debug against it. Perhaps build a tool that crawls 10 different archives with 10 different protocols to try to make a sort of a search engine for data and try that out in that environment and so forth. And collaborative support, basically providing development support for these tools through developers that basically work across a number of different projects, from DIBs to data nets to SI2s and so forth at NCSA and these other organizations as well. And so that's one of the tools, and then I'll just finish up with the second tool here, which is kind of ramping up, which is a portion of this activity which we call NDS Share, which is going more towards the line of what a national data service might look like, as sort of a portal to all data that's out there, regardless of what technology it's behind, what archive technology, what storage it's actually on. And you could think of it kind of like as a Google for scientific data kind of thing. And so what we've been building there is a resource that would kind of foster that. So in terms of archive technology, data publication, there's a lot of tools out there. I won't go into too much details of this because I'm certain I'm running out of time here, but there's Globus Publish is one example where you can basically it's an extension of Globus Transfer where you can basically publish data sets. You basically upload a data set, put in some metadata, and basically at the end of the day, get a DOI or some other handle that you can then reference that data set by. DataNet Seed does a similar thing. It's got a Dropbox-like interface. You can put data there, and same kind of process. It'll find a repository for you, get a DOI. Dataverse has been around for a while. You can do that with. And so what we built for this kind of world is something of a useful tool that can be leveraged by all these things for something that's becoming more and more prominent these days, the need to run analyses next to data sets. And so trying to be agnostic to technologies, but building something that each can leverage, we've begun working on this tool we refer to as a data DNS. And what it is kind of analogous to a traditional DNS that maps URLs to IP addresses. What it does is it maps digital object identifiers to data sets to the specific locations, whether it be one or more, where that data set can be located, and further mapping it all the way down to a path on that system where that data can actually be mounted. And so what this does is it allows any of those tools to then basically take that information and without actually having the data stored there, referencing that data set, and launch tools next to the data. So if the data is too large to move, it's a terabyte or more, leave it where it's at and launch a Jupyter Notebook next to it, an RStudio notebook next to it, a Dockerized container next to it, and so forth. And so we did a demonstration of this at Supercomputing. This is kind of a web portal interface to look at the data DNS entries based on its citation and where it's located. And you can launch a notebook from here, in which case if you press the button, it brings you to a Jupyter Notebook. You can run it and get some sort of visualization on some data set at some remote location. But the idea here is to leverage it in all these data management technologies that currently exist. So in the Globus Publish case, basically imposing on it these little buttons down here where you could just run some sort of tool next to the data. DataNet Seed, same kind of thing. Basically impose this capability right on it. Dataverse, same kind of thing. So we're working on basically doing this through means that minimize the effort on each of these activities. We're working on a bookmarklet, which basically contains JavaScript inside of a bookmark that you could potentially run on Dataverse, Globus Publish, DataNet Seed, and it will automatically stick this button on them without having the developers of each of those projects actually do anything. And so that's kind of the angle we're taking on that, and it'll be one component of this Google for data that will be NDS Share at some point. So this is kind of a first step. So I'm going to end there. Those are two of the technologies we're working on at the moment. There's YouTube links in these slides that'll be online, so you can actually see them running. And if there's any questions, I can take them now.
I have a quick question. How each researcher, like at big data community, can contribute to this NDS?
Mm-hmm. Specifically to one of the things I showed, like labs or the data DNS?
I think in general, I know NDS, but I don't know how each researcher such as doing big data related research, and they will provide their tool to be connected, or they can try to link different tools?
Yeah, so on our webpage, there's a link to submitting pilot efforts. And so if you do that, there's a little form you fill out and basically propose what you think basically will be beneficial in connecting some components and developing some technology around that. And we review those periodically, and with that provide resources and work with you towards enabling that kind of thing. So that would be a one way to do it. The other would be attending the workshops that we have every 6 months and engaging us there, I would say.
Open it up.
Hello, this is Regan. I had a quick question about the status of the RDA test bed you proposed.
I don't know that that's gone very far yet. So the idea would be that the NDS Labs could serve as that purpose, but I don't believe we've done much follow-up in terms of making that happen yet. The NDS Labs Workbench is still in its alpha stage. The beta release of that will be in the next month, and so that would be when it's more stable. But I don't believe we've followed up too much with that at the moment.
Very good.
This is Leah. I really liked your App Store storefront that you showed. When we had our hubs, we're having a series of meetings for strategic planning for the South Hub with our PIs and my counterpart Renata Rowling-Goss and our teams. We came up with a similar conclusion that that was needed. Is this something that you've been working with the Midwest Hub to provide? Is this something that could be expanded that all the hubs work with you on? And also, how does it relate to what Exceed provides in their tools and resources?
So in terms of need, yeah, we have seen this cross need, and specifically from EarthCube. We've been involved with the EarthCube Architecture Committee, and this kind of thing came up there after the fact too, and so I showed it to them as well. And as I mentioned to them, it's open source, and we welcome contributions from anybody, and anyone is welcome to skin it as they wish too for their specific endeavor. What we're trying to do is basically catalog these tools in Docker containers, and however that's done, it could be shared across any of these instances at some point. So I think for the greater good, however it's branded, it's good to have to basically help us build up this tool base of all these different data management technologies.
Are these tools open source, or is there a mix of open source and closed systems? Is it just for academic researchers, or could private sector folks also come in and use these tools?
So currently it's all open source. Potentially private stuff could be in there, but we're not addressing that at the moment. That's a whole different can of worms. And so there's plenty of stuff in the scientific community that's open, and so we're tackling that at the moment.
Okay. Well, I'd like to, if Mike and I and maybe Stan and others could have a follow-up